Thank you. I think it's my second public speaking ever. So I work as a software engineer at Google. I'm with GitNation since 2016, helping with conferences. At work, I work on AI data pipelines and AI developer workflows. So today's lightning talk is about loop engineering. So everybody knows this quote from Boris Cherny, and I was thinking about it a lot as well. I've had some thoughts that maybe prompt engineering is dead, and new products by Anthropic are now developed with magical loops like Claude tag and so on. And what is that? Apparently, it was not. And loop engineering was basically designed to replace these moments where human judgment becomes a bottleneck. Models became super fast. Claude got fast mode. Codex got fast mode. They're coming back to you very quickly, waiting for a next decision, and you are basically being chained to a machine with a model waiting for a next prompt. Solution to this is writing loops to automate decisions which human is not necessarily needed, like writing tests or splitting your task into parts and so on. So in order to start doing loops, we need to ask ourselves which decisions we can automate. These decisions are what to do next, how to split work, what context to load. There was a research by Geoffrey Huntley, which is, by the way, very famous for inviting a Ralph looping model. And he concluded that only first 146,000 tokens are meaningful for a context, and then model starts to drift and hallucinate after that. So what can loops build? With loops, we can obviously maintain repository, do migrations, build small product features. We can even build full applications and languages from scratch. And I'll go through a couple of real-world cases. So first would be a programming language, Cursed. It was developed using loop engineering. Loop was running 3 months, and the result was a fully created language. It worked in a way author had a prompt.md file, which was checking fixed plan.md and executing it, updating plan for itself, and executing it again for the whole 3 months. In order to do that, author pre-created a directory with specs, put the basic information, how language should work, grammar, memory management, concurrency, how LLVM should be structured for it. Created an Agentic with some basic guidance on if model learns something, how it should proceed. And as a result, after 3 months, he's got a fully working programming language with funny Gen Z syntax. Another few seconds on the slide. Important note about this loop. A language was developed by a system constantly updating fixedplan.md. It was comparing specs and source files. It was writing what's missing as a prioritized list. It was constantly picking what's most important and forming a new to-do list for the next iteration. So important takeaway from here would be that repo state always tries to loop. A second research was it actually ended up at the top of Hacker News for a while. Guys from Y Combinator created 6 projects overnight. 3 of them were just translating code from one language to another, and some experiments just creating projects from spec files. They achieved their goals. I think the budget was $50,000. They spent $800 on this project. There are QR codes for this research, and that will be shared later. So what about it? after this obvious success, in the morning they've got repositories translated. Obviously, Claude was good at that. They decided to refactor the code base in a loop. They ended up with a huge CL, a huge PR, which had 20,000 lines of code. And that loop ended up with creating 1.6 thousand to-do items, which were basically unverifiable. And next morning, when they woke up to this PR, they checked it. The rumors were they said it was nice, but they ended up not merging it because no human can verify that. And another takeaway was that actually speed of a loop moves the bottleneck. So apparently we are creating loops to help us moving on projects faster by eliminating the need of making some decisions. But in the end, we ended up with how fast we can be to make certain decisions for a loop to proceed. And this pair was a good example on that. So general conclusion from both cases, we should be handing off repetition to loops, but still for some cases there will be human judgment. So what we should automate, obviously a task should be recurring, checkable, and bounded. So recurring, obviously there is no point of writing loops for something like one-off task. Checkable, obviously, we don't want LLMs to be too creative. As first speaker Pat from Apollo, models became good at lying, so verification is a must now. And bounded. Again, example with pair showed that if we're creating a loop for something, it should be able to do it in small steps, small verifiable steps. And now, I think like the biggest question with loop engineering is it suitable for creating full-blown apps? And like language example was good, but quite synthetic. And as a kind of last part of this presentation, I want to guide you through creating a simple project yourself using loop engineering. So every project which will be implemented using loop engineering has 5 moving parts, 4 MD files and a bash file. So MD files, obviously we should have spec, and spec will always be a guidance on what we should get in the end. Think about as a design doc or product design doc, which just says which product we want to get as a result. This should be created with a model assistance. It's not created in a loop. So you should have an idea, you should run it through LLM, you should generate this file yourself. Then there is a plan which is created with spec. So basically going with LLM and trying to split it in chunks, like what should be implemented first, what should be implemented next, and so on. That would be like a initial plan, a core of your loop. Then AgentsMD, it should just dictate agent how the project will be executed, how should be built, how tests should be run. We'll talk about tests a little bit later. ProgressMD, which will be just tracking an execution of loop. Yeah, okay. Yeah, and loop which executes a loop. Okay. Unfortunately, I have 1 minute, so I'll just fly through spec, plan, agents, ProgressMD, which extracts progress, loop.sh, which executes a loop by reading all the files in while true form. Yeah, important note about tests. When we are doing loop engineering, we should have tests as a read-only, because LLMs tend to rewrite tests if they're allowed to do that. Yeah, so tests should be read-only. If you're adding tests on a project, they should be created by a previous step of a loop. And when you are scaling the system... Sorry, I just ran out of time and got a little bit nervous. So tests are read-only. If we need to create tests, we're creating them by a previous loop iteration. Then if we are expanding our project and we're thinking how can we improve our loop, we should be starting by adding a verifier agent, which basically takes the previous step, verifies that it runs fine, makes a verdict if it pass or fail, and why if not. And if verifier fails, there we have a human intervention and to actually make a decision on how loop should proceed. Then if we want to add a system which creates new backlog task, we can add another agent which will be reading a full goal of a project like spec.md, and within a spec see which more tasks can we add. And after that, if, for example, a project is involved in complex tasks, not necessarily long-running tasks, we should think about adding a cron or modifying plan MD to have more indication to other agents on how they should perform together in the code base. So should you use loops? Yes, when the work is repeated, checkable, bounded, and blocked mostly by user attention. And I encourage everyone to start with loops today. We just need to think a work which we are reprompting model constantly, manually. Decisions that follow the same rule, and checks where we simply say pass or fail by just glancing on them. And of course, using loops is only possible when we have a definition of done and good. If we don't know what we're building, if we don't know what's the definition of done for what we're building, then loop is not applicable to that. Thank you.